Looking at number 5 on the optimization worksheet. The size of a population of bacteria introduced to a food grows according to the formula P of T equals whatever, where T is measured in weeks. Be careful with that. Determine when the bacteria will reach its maximum size. Well, what is the maximum size? So find T, maximum size would be P. So we need T and P at the maximum. So if we want to maximize P, we need a P prime, which means I'm going to need the quotient rule. So F is the top, so F prime will be 6,000. G is the bottom, so that'll be 2T, or G prime will be 2T. And then the quotient rule is GF prime. GF prime minus FG prime. Ugh. 12,000 T squared. You will have a calculator on the test, so you can avoid, well, not avoid, but help with crazy numbers. So there's P prime, the derivative of P. GF prime minus FG prime over G squared. Guess we should clean that up a little bit. 60 times 6,000. That would be 36,000 with an extra 0, I think. Yep. 360,000 plus 60,000 T squared. Nope, 6,000 T squared minus 12,000 T squared. All over. I am not squaring that out, and I'm not going to mess with that because it's never going to be 0, right? If I square something, it's positive. If I add 60, we're positive. If I square it again, I'm positive. So I'm not really worried about this. I'm trying to set P prime equal to 0 or undefined, but the bottom's never going to be 0, so I'm not really worried about cleaning that up. I am worried about the top. 360,000 minus 6,000 T squared. So let's set the top equal to 0. So 6,000 T squared equals 360,000. So T squared equals 60. Because I set the derivative equal to 0, so let me go an extra step there. So T, like mathematically, T would be plus or minus the square root of 60, but since T represents time and we're not going backwards in time, I don't have to worry about the negative. So T is the square root of 60. That's my only possible answer. So I'm supposed to check this against the second derivative, but I think I'm going to pass on that, and on the AP test that would be wrong. I can't do that. But it's the only point I've got, so I'm going to trust that that's the maximum. And then I need to find P at square root of 60. Well, that would be a calculator issue for sure. So 6,000 times square root of 60 divided by 60 plus square root of 60 squared. I can do that without a calculator. So my answer is 387.298. that one had a quotient rule thrown in there. So all these problems that are applications of derivatives means we still need to know how to do all the derivatives, including things like quotient rule, sines and cosines, all that stuff. Number 6 on the optimization worksheet. Blood pressure will drop by an amount where D equals that expression, where X is the amount of drug injected. So D is the drop. Find the dosage that provides the greatest drop. So I want to maximize drop. I mean, that seems a little bit weird, like that does not seem like a minimize, but this is phrased as a drop, so I want to maximize this. I want to maximize D of X. Find the dosage, so that's X, and what is the drop? So that's D. So it's a little bit like number 5, where it's asking for both pieces. Find what value of X maximizes the drop, and what drop is it? D of X. Oh, I'm going to do some algebra first, so I don't have to use the product rule. But I'm going to use a calculator so I don't mess up my algebra. 30 times 0.025 is 0.75 x squared minus 0.025 x cubed. Not calculus yet. That's algebra because it makes my calculus easier. So the derivative would be 1.5x minus 0.075 x squared. I'm going to have 2 answers on this one, and I'll probably need to check which one's the max or verify that it's the max. So set it equal to 0. I'll factor out an x. X equals 0 is one answer. The other answer is 1.5 divided by 0.075 is 20. And in the context of this problem, X is how much of the drug we get. D is the drop. Well, I guess I shouldn't rule out 0 yet, but I'm pretty sure if you inject 0 drug into the body, you're not going to get any effect of the drug. So I'm guessing X equals 0 is a minimum. But let's do a second derivative just to make sure. (1.5 minus 0.15x). So the second derivative at 0 is positive. So that means X equals 0 is a minimum. I mean, that makes sense. We're not injecting any drug. We're not getting any drop. The second derivative at 20, 1.5 minus 0.15 times 20 is negative. So we're concave down. That means X equals 20 is a maximum. So that's what we want. Find the dosage. That's X. Okay, so that's our dosage. We're good there. And find the drop. So I need to find the drop when X is 20. And by the way, this is sufficient for showing your work on the AP test. If you write D of 20 and D is already defined, like you don't have to show plugging it in. Like they know that you know how to use a calculator, and that's all you're going to do here. So you don't have to show that you plugged it in. You can say D of 20 and they know what you're going to do. And the drop is 100. I'm checking for units. X is the amount of drug ejected in centimeters cubed, so I guess I should say centimeters cubed. It does not tell me what the drop in blood pressure is, so I don't have a unit for blood pressure.